Hello, everyone. Imagine you're sitting in a room and suddenly you catch a sweet whiff of perfume. That's adsorption happening right in front of you. What's going on here is that the perfume molecules are sticking to the surface of the air particles, spreading that fragrance all around. Adsorption is the process where a substance attaches to the surface of another, usually because the molecules at the surface of a material are not fully surrounded by other molecules, so they attract and stick to other substances. Think of it like how dirt clings to your clothes. It's all about surface attraction, where one substance sticks to the surface of another. Now, let's break down the key terms in adsorption. First up, we have the adsorbent. This is the surface that attracts and holds onto another substance. For example, activated charcoal acts as an adsorbent. Then, we have the adsorbate, which is the substance that sticks to the surface. In this case, if we take ammonia gas, it's the adsorbate. So, in simple terms, the adsorbent is the sticky surface and the adsorbate is the substance that gets stuck to it. Let's clarify something that often gets mixed up: adsorption versus absorption. Here's the difference: adsorption is a surface phenomenon. Imagine a sticker on a wall. It sticks to the surface but doesn't go inside. On the other hand, absorption happens when a substance is taken in and spread throughout the material, like a sponge soaking up water. So, adsorption is when things stick to the surface, and absorption is when things spread throughout the material. Remember, adsorption stays on the surface, while absorption goes deep inside.
Now, let's talk about the two types of adsorption: physical adsorption and chemical adsorption. Physical adsorption is like sticking a piece of tape on a surface. It's weak and you can peel it off easily. This happens because of weak forces called van der Waals forces, and the adsorbate forms multiple layers. On the other hand, chemical adsorption is much stronger, like superglue. Once it sticks, it's tough to remove. This happens because chemical bonds are formed between the adsorbent and the adsorbate, and it usually forms just one layer of the adsorbate.
So, what affects how much gets adsorbed? There are a few factors to consider. First, the surface area of the adsorbent. The larger the surface area, the more adsorbate can stick to it. Think of it like how a big sponge holds more water than a tiny one. Second, temperature. For physical adsorption, when the temperature increases, the amount of adsorbate decreases. It's similar to how heat makes soap bubbles pop faster. Heat weakens the forces holding the adsorbate. And lastly, pressure. When the pressure increases, more gas gets adsorbed. It's like pressing down on a sponge to force more water inside. Now, let's dive into some science. Adsorption isotherms are used to describe how the amount of adsorbate changes with pressure at a constant temperature. One common equation for this is the Freundlich adsorption isotherm, which is written as x divided by m equals k times p raised to the power of 1 by n, where x divided by m is the amount of adsorbate per unit mass of the adsorbent, k is the constant specific to the system, p is the pressure, and n is a constant that depends on the system. This equation helps us understand how gases behave when adsorbed onto solid surfaces. Alright, let's work through this problem step by step. We are given that the amount of adsorbate adsorbed on a solid is 0.5 grams at an equilibrium pressure of 2 atm. The constant K is 1.5, and we need to find the amount of adsorbate at a new pressure of 3 atm. To solve this, we'll use the Freundlich equation, which is x divided by m equals k times p raised to the power of 1/n. Now, let's substitute the values we know into the equation. We are told that k equals 1.5, the new pressure p is equal to 3 atm, and n is equal to 1. So, the equation becomes x divided by m equals 1.5 times 3 raised to the power of 1 divided by 1. Since n is 1, this simplifies to x divided by m equals 1.5 times 3. Now, calculating that, x divided by m equals 4.5 grams. So, at a pressure of 3 atm, the amount of adsorbate adsorbed on the solid is 4.5 grams. And there you have it. The problem is solved. Let's quickly recap what we've learned today. Adsorption is when one substance sticks to the surface of another. The adsorbent is the surface and the adsorbate is the substance that sticks. We also saw that physical adsorption involves weak forces, while chemical adsorption involves strong chemical bonds. Factors like surface area, temperature, and pressure all affect how much can be adsorbed. And we explored how adsorption isotherms help scientists predict how gases behave when adsorbed onto solids. So, to sum up, adsorption isn't just a theoretical concept, it's something we see and use in real life, from air purifiers to catalysts. I hope this session helped you see how chemistry is more than just equations, it's all around us, making things work. Catch you in the next class, where we'll explore even more fascinating concepts and how they shape the world we live in.